Hey everyone, thank you for stopping by today. Today I'll be presenting my Ariana glider project for my AE1601 course with Dr. Zaid. The objective is to design, build, and flight test a small glider for a final style fly-off class competition. The requirements, also known as a measure of success, the glider must be hand-thrown, must fit in a 16 by 16 inch box, and the vehicle shall remain intact during flight. For this competition, the flight target range must be greater than 20 feet off the ground level. My initial design for this glider, it had a elliptical wing shape and a Tita design. The glider is named after Ariana Grande, and the material is constructed from balsa wood, wood glue, and Play-Doh. If you look at the very bottom to the right, I sketched a top view and a side view of the glider. This is the listed dimensions and a picture of the build off. So before continuing, I did build my first initial design. Unfortunately, it crashed due to the tail being due to the tail being heavy. So analyzing my first flight, I had to switch to a tapered wing with the help of the AMS mentors and a few articles I read, and I realized that the tapered wing, it does has a high aspect ratio, and it was easy to manufacture. Unfortunately for the elliptical, it was difficult to manufacture, and it instantly stalls due to its wing shape. As for the front wing iterations, the material is now made out of basswood, 13.5 inches, and is very beneficial because it rearranges the center of pressure due to its weight, and the wing location is now 13 inches from the from the fuselage. The T-tail, I did realize that it was difficult to manufacture, and with the added weight of glue and time consumption, it was very poorly to manufacture. So as for the conventional tail, it was easy to manufacture, and it was a less time consumption. And also, a conventional tail is very beneficial for its positive dynamic stability. The T iteration is now a conventional tail. It's very beneficial. It's very beneficial for its added stability, and now the horizontal stabilizer is located in the bottom of the fuselage. And sorry, the shape is tapered. Yeah. And also looking at the nose tip, I realized that my initial design is shaped as a Q shape, and I realized that looking at the few lectures previously, the drag coefficient of a Q shape is 1.05, and it's very unstable for aerodynamics purposes. So I did switch it to a streamlined half body, and I believe it's now estimated to be a 0.09 drag coefficient, and it's very stable for fluid flow, and it's aerodynamics friendly. So the iteration now is shaped as a streamlined half body and with a payload of 0.0063 kilograms of Play-Doh. So this is the picture I posted of how my final design is going to look like. It does has all the requirements of the measure of success. So looking at the video, it does indeed roll. So my final iteration was to put the Play-Doh onto the wing. Reason why? Because it now does reduces roll, so it could perfectly flow. Will fly stable. So now looking at the video itself for the final flight day, the Play-Doh does indeed help a lot, and now the glider flies perfectly, and it successfully flew 50 feet from the ground level, and it indeed the glider remained intact. And now the CG location is roughly 16. Oh well, is roughly 3 inches near the front leading edge, and the glider weight is 0.0025 kilograms. With the help of the lecture slides, I did calculated the aspect ratio, lift coefficient, and the induced drag coefficient, as shown in this slide. So overall, the glider report was a successful. It did satisfy the 20 feet flight range. It did remain intact, and overall, it was a fun project. I did learn a lot in aerodynamics and in flight controls. And I do want to pursue my interest in aerodynamics after this course. And just overall, just for a future reference, it really depends on the hand throwing because you could perfectly engineer a glider. However, if it's not thrown properly, it will not just succeed. So these are my reference, and thank you.